Wait for a little bit of the schedule. Hello everyone, so my name is Robert Snyder. I am a developer with Press Ganey. I've been in professional development for the past 5 years approximately, but I've been doing it for much longer as a hobbyist before then. Before Press Ganey, I was with my previous company, Data Limited Incorporated, where they built rugged tablets, and I was first I was the apprentice, but then I ended up becoming the lead developer there, and that was quite a big project for me. We did the last project I worked on while I was there was implementing tap to pay at Disney. So it was definitely the need for automated testing in that respects. As many of you are probably thankful for if you've been to Disney. You're probably glad that I did some unit testing, as you probably didn't want to see $200 charged for a $20 transaction. So, as is noted, the title of the talk is Automated Testing, but it works in production. And it actually stems from a dialogue that I had with a coworker at Data Limited Incorporated. As the lead developer, because I was up here in LaPorte and my team was down in Florida, I didn't often get a chance to bark out orders at them saying, oh, you got an automated test, you guys do this, you guys do that. Instead, I was getting much flack because I spent extra time writing tests for my code to make sure that it worked, whereas he wanted to get it out to production, show everybody the cool new features that he just added to it, and click through. In this case, he was making a website. But so we had many talks about this, and his concluding words was, but it works in production. I couldn't argue that fact, and I did try with the manager, and he said, well, he's right, it does work. Okay, well, so it goes. You win some, you lose some. Let's see if I can get Sway to work here. I'm new to Sway. So, about automated testing. Do we have anybody here that hasn't worked with automated testing? That's getting to be kind of popular lately. Anybody? Okay, so, yeah, I got one target audience.
Lots of unit tests, but not.
Well, it's the same thing. Okay, and I'll be discussing the same thing. So, I mean, as you can see in the background picture, less than 1 millisecond to execute a test. And less than 1 millisecond, well, that's fast. And the nice thing about it is that many of your unit tests can be small. They're supposed to run fast, and I'll get to why. And the premise behind a unit test in general is that you're just testing your method logic. And another thing that I really want to talk about towards the end is some of the pitfalls that we might run into with unit testing. Because frequently, you can find many examples out there online that they show making a unit test, but it's more geared towards fixing this one specific implementation problem instead of looking at the bigger picture and try to solve the overall logic and give you a good sound final solution to your problem that you're facing. And I have a good example about myself on that in general. I forgot to mention that. Let me go back a step here. With your testing in general, if you can imagine a pyramid type shape where you have number of unit tests. There at the very bottom, you'd have your unit tests. You're going to have a ton of them. They're going to run really fast, and they ought to, because otherwise you're not going to want to run them. Above that, you're going to have the next thing here is acceptance tests. Above that, integration tests, and the very top end-to-end tests. Now with acceptance testing, this one is a little more difficult, and I'm going to tell on myself where I barely wrote any acceptance tests. My manager, though, has informed me that I'm wrong. I need to write more acceptance tests, and the reason is that your acceptance tests are going to show more or less business, or those whom you're writing your app for, that it is working as they said it should. If they said that it needs to do A, B, and C, and you can show in a test with big, pretty green colors that it does A, B, and C, or they want to periodically check up on you, okay, well, they got A working, B is still failing, so I guess it still needs a little bit of work, and C is still gray, so it hasn't even been touched yet. So it can possibly give business or whomever is interested in your product some insight as to how progress is going. However, because a lot of people don't focus on it, many people who do write them end up making what I've termed throwaway tests. You write them poorly to the point where it's like they become so fragile and so brittle, and the slightest breath of wind or your database occasionally returns a couple extra variables, and everything goes in haywire, and you're like, you just throw it away, you don't run them. It's unfortunate because they should be run frequently to prove to others that your app does work as intended. Plus, if you end up doing a large refactoring, you can really easily and quickly show that you're still making all of your business requirements, and that essentially regression testing is where I'm going with it. You get to show that everything is still working as intended before. You can cut back a lot on your QA time, how much time they spend regression testing. One of our projects at work, they spent well over a week doing some regression testing on a rather large app. I felt sorry for them, but then again, I wasn't a QA person, I was the developer, so. Yay for me. My mouse pad's not so sensitive. The next tier up, which would be your integration tests. Now, integration tests are a little more finicky. In fact, they're a lot more finicky, because typically with an integration test, you're going to want to talk to your external resources, your database, your file operations, your whatever is not local on your PC. You're having to make calls out to whatever. That's what you're going to want to test that is wired up correctly. You just switched, in this particular case, it's perfect for switching technologies. You were using it in Hibernate before, but now you want to use Entity Framework. Boom. This is where it's perfect, because you have all your tests set up. It lets you see that, I was making a call here, I was getting back all these different entities, and now that I switched to Entity Framework, I get back half of them. Well, now you have a very quick and accurate way to show you that it is indeed working. Some of the problems with integration tests is that they can be difficult. In fact, earlier today, when I was pairing with Brian, ran through all the tests, and one or two of my integration tests failed because my hardware was running a little bit slow. Ran it again, passed. It happens. It's not the best thing in the world, but with integration tests, you kind of want to keep that in the back of your mind that they are slower, they are prone to having little hiccups, network interference, hard drive problems, whatever the case may be. But if you can run them again and show that they are working still, then you're typically golden. You don't want to write an absolute ton of integration tests, strictly because of that fragility that is built into them, or what's inherent to integration tests. And, well, the reasons is because people start freaking out when they start trusting your tests, and they see, oh no, they're starting to break kind of frequently. They start to take a little less merit into your tests. And the last one, which I have yet to see or write any end-to-end tests. I've heard of them. I know they exist. But they are probably one of the most difficult things to write. If there are those who have written them, I applaud you. Good job with them. The idea behind them is that you want to test your entire system, A to B. User clicks here, it goes into here, but if they went to this place where they shouldn't have, I want it to blow up and send an email out to Mary Jane that the system is all messed up and that we need to have some drastic measures taken. But they're difficult in the respect that because they are from such a far level back, or such a high level, any slight little changes that you make in your app could potentially break your end-to-end test, and rightfully so, but that therein lies the difficulty with writing them. They can be written for non-technical people. I've seen this very similar to what an Excel sheet looks like, where you have a set of tests, you have a set of criteria that it's going to execute against them, and this is the outcome of it. And they should be very quickly be able to tell at a glance, what's going on with them. I think the .NET Core, if I'm not mistaken, is one of the big ones that has a large end-to-end test, thankfully so. They run it after they check in their source code. They have a long, last time I checked, it was like a 7-hour test running time frame. That's another reason why you don't want to run them, because I don't know about you, but kick off the build at the beginning of the day and twiddle your thumbs for the next 7 hours doesn't really sound too exciting to me. So that's them in a nutshell. So before I start showing some code, do we have any specific questions going in here before I start talking about some of the pitfalls? In clear terms? Yes?
Are you going to talk at all about when does it become obvious that you're just re-implementing your entire system using testing versus enough of a framework to just confirm that your components?
Yeah, in fact, that is one of the pitfalls that I would like to address. So, here we go. Let's see if, oh, vehicle holders, I forgot I added that. Wonder what mood I was in when I wrote that. So you gotta write more code, you know, and very much to your point about, man, you know, I just got done writing this and now you want me to basically duplicate exactly what I was showing the other people? Well, yes and no. You can write your tests in such a way that you're not so much just duplicating everything that's out there. Instead, you're going to be changing your mindset on how you approach a problem. And some of what comes up from duplicating essentially your code is how you're approaching the problem to begin with. If you go in there with a testing mindset of, you know, knowing that, okay, well, I might have a loophole here and here, so let's make that testable so I can make sure that none of those little loopholes get SQL injection, for instance. I can test that those things are indeed not going to be a problem in my system now, and if it does end up becoming a problem, I can add another test later that show that this isn't a problem. Quicker bug squishing. Now this one came in very handy for me when I was writing the first part of the Disney project. Was I was writing code to be able to use the Magic Band wristband to get into the rooms, and part of the logic that was in there was being able to write an encrypted guest key, as it were, to that Magic Band so that they could get into your room, and eventually they wanted to use it so that you could pay using your guest key. Well, there was a problem where every 7th or 8th time that it tapped, it would the system would just overload and it would use an insane amount of memory, but my development machine had a ton of memory to begin with, so I never really noticed it. But when I was able to write a test that showed multiple taps, I did a memory dump. Oh, whoa, that was a lot more than I was expecting. But the point I want to get with it is that I was able to write those tests in about 5 minutes, and then I was able to see my results in probably a total of 10 minutes, and I was able to fix the bug and get a solution out to Disney in a little under a day after the QA person wanted to get a hand on it. I've seen hints at faster development, and there is a kind of a gripe of mine about that. When I first started with the whole test-driven development mantra that everyone was screaming about quite some time ago, and I still appreciate it. I do like to write my tests first, and I still feel awkward about writing code without having some sort of test in place. I felt slow. I felt awkward. It was difficult. I didn't know how to write the test to begin with. I was writing, much to your point again, I was writing essentially the same code that I was writing in production, and I was literally copying and pasting a method out of my test into production code because I knew it worked, and then shipping out the product. But I wasn't necessarily testing correctly. I wasn't writing test code correctly. I was also, I got a good story about my test being brittle. One of the projects previous to that was I was to update a project that we had that had a config file. It was an XML config file. And that was the most brittle setup. I probably wrote 50 or 60 some odd unit tests around reading in this XML config file and being able to write out the context. Well, the contents of it. The problem with it was I was approaching the problem entirely incorrectly. I was showing that, you know, when I write this XML to a file, that it needs to look exactly like this way, and when I read it back, I need to make sure that it was written correctly to begin with, and that I get the exact same results out. A lot of you probably already see the problem in that is that as soon as my config changes, my XML structure is going to change, and therefore my tests are going to break, and all 7, 8, 9, 10 days that I spent working on getting those tests working are now failing. And then I came across another problem with the same area where there was other versions of the same program out there I didn't know about, and their config file was different, and I had to be able to accept them all. I was angry at myself. There was a different approach altogether, and I'm glad I know it now, but at the time I didn't know about it. So many days wasted on that, and I was angry at testing, I was angry at myself, I was angry at everybody who suggested that we should be writing unit tests for everyday life. And the same on the other, I was hypocritical in the respect, because I was like, people that I was talking to about this, I saw the great merit in it, so I was telling everybody, you know, hey, you need to unit test, and it became my golden hammer, as it were. I was out there screaming at people, I need to write tests, and in the background I'm like, oh, yeah, but I write horrible tests, and they're not quite right. But there are things that are just generally not testable, and some of the work that I did do was just plain and simply not testable. The NuGet stuff that you were talking about there, I tried writing tests for that because it was before they had the NuGet spec command. When you showed me that, I was like, whoa. I hand-coded the new spec XML file. I hand-coded all the PP files in there, and I hand-coded the project as it was supposed to be, and edited them outside of Visual Studio, and packaged it up and sent it out, and I had tests around it, and I was super happy. And then I had to change the name of the namespace, and everything broke. Some things are just not testable. The way that your program looks and feels. Are you going to go out there and test your CSS that this box is 15 pixels high and this one's 25, and you have a 5 padding here? No. Your eyes are going to be able to tell much faster that something is aesthetically pleasing and not messed up. If you have boxes on top of a box, or you have a button behind a frame, you're not going to be able to see that in automated tests. And if you can see it, you're spending way too much time writing your tests in this particular respect. Hardware communication. This is one that was another one for me to swallow, because it was like, I did do a lot of hardware communication. I was talking through RFID, I was reading and writing to a Magic Band, and I was reading and writing to RFCs, to cell phones, and I felt that beyond a doubt that I could test this and everything was going to work and it was going to be hunky-dory. But past couple of days, before I came and gave this talk, I looked over some of that code, some of my unit tests. That last point there, heavily complex and dependent upon code, yes. I tried to compile my code, doesn't compile anymore. I saw the logic, I understood what it was trying to get at, but I couldn't compile. I was dependent upon hardware that I no longer had access to. It's my previous job. It required libraries that were only available at my previous job. Some of the things that I needed to have at my disposal, some of the Visa test cards that we got back, I didn't have those at my disposal anymore. So many of the 200 some odd tests that I had around it, I think I got 20 of them to work at most, because it was dependent upon those things. So yes, write more code, but be careful on how you write it. And with the code examples, I hope to be able to spit that out there. There's different testing styles out there. You heard me briefly mention TDD. There's also BDD. The terminology stand for test-driven development, and you have business design. Behavior-driven development. Thank you. Similar mindsets, where you want to write a failing test first, you want to make it pass, and you want to make it look good. They're same concepts, but the commonality between them is that you're going to make a new class. It's going to be inside your project. You want to have the name that you're testing of your class and add tests to the end of it. Your languages are going to dictate how that exactly looks. Many of your different test frameworks are going to have some type of setup that's going to be required, either for the entire test fixture or for the exact method that you want to test. You're going to want to invoke said action, and then you're going to test the state. And that was another one of my problems. I wasn't testing the state, I was testing the way that I wanted it to work. And that gave me many, many headaches. So we already talked about test-driven development, how you want to start with nothing and you want to come up with a complete test. I've typically found that test-driven development is usually only good for small things. I've yet to have anybody prove me wrong in that. I'm not saying that I'm right, I'm just saying I haven't been able to be proved wrong that test-driven development is good for anything outside of writing your intricate little tests. Yes?
Yeah, that was kind of what I was trying to get at. So your experience also has been the unit tests are really good for state in, state out, but not interaction of multiple subsystems.
Yeah, and in fact, that is going to be more of where your acceptance tests come into play, where you want your repository to talk to your business layer to bubble up to your view. Yeah, that is exactly where your acceptance tests are going to be from, and they're going to be written in such a manner that, let's see if I can remember my test. When a survey comes in that had multiple surveys that were sent out, if multiple of them were returned, then I want to send an email out to the manager that I didn't write all of that, but it was very close to that. And the test showed that, okay, I got back a survey, there's multiple surveys in the database. I didn't write to an actual database, I marked that out. I sent the message out to the system, and then I expected that after a little while that it indeed sent out said email, a fake email like that. I also find too that test-driven development oftentimes has you too focused on the explicit implementation that you are trying to write. Going back to my XML example, I found that I was so concerned that the brackets were a certain size and that I only had so much spacing in between them and that all my elements were spelled exactly correct and that my casing was correct and that the values inside the casing was correct, that as soon as it changed, it threw that all out the window. Not to even mention, if I switched to JSON or some other format, or I switched to, I think at the end, I was wanting to switch to SQLite because it was for an embedded system, and we also wanted to port it over to Android. It was going to get ugly fast, and I was the only one to blame because I was too focused on keeping that XML. So, business-driven development, behavior-driven development, same concept. I feel that is a better way of approaching the thing. Instead of getting your horizontal slices of solving your problem, now you're looking at the bigger picture. If anyone familiar with the vertical slices and horizontal slices mantra? Okay. Yeah, it was just on our calendar there. I think that actually helps you envision your whole project at a much grander scale, being able to take a step back and think about, okay, am I really that concerned with XML, or should I just be concerned that I'm getting a configuration object? Wish I would have realized that. I have no clue what I might not find a little nuance introduced in specific technologies. I don't know why I wrote that. Characterization tests. Probably one of my more favorite types of tests to write, strictly because they are catered towards legacy code that is in existence I'm sorry, I use that term a little too liberally. Code that has no tests on it whatsoever that you need to make a change to, but you don't know how it works at all. Well, that's where I really like characterization tests, because they are going to let you, in isolation, away from production, hopefully, be able to test that your application is indeed, or that it can at least give you some idea how things are supposed to work or how they are working in their app. I have a good example that I would like to show here in a second too. Hopefully I'm getting towards the end of my thing there. So that's what I have about those particular things. You can get in touch with me. I'm frequently on Skype and I like to talk on there frequently. But the thing I did want to promise was, let's see, which way do I got to go there? Some code. Oh. Come on, Visual Studio. Is it left? Okay, so this is the project that I was talking about with the whole XML. I still have access to my source code from way back when. I know it's kind of small, so let's make it a little bit bigger here. Actually, you know what? No. Let's make it small to give you an idea of just how much code. This is for one config file. Just to read in the configure. Oh, I have regions in here. It's even bigger. Yeah, 400 lines of code, 300. Okay, that's not on both screens.
More than the original library or less?
Huh?
Is your test, you have more lines of tests than the original code or?
Oh yes, way more. There was 37 lines of code to read in the config file. And as you see here, I wrote probably 350-ish lines, excluding white space and regions and names there. I ran these tests beforehand, almost all of them break. Why did that happen? I was way too focused, as I've said multiple times already throughout this talk. I was too focused on the XML. Had I took a step back and realized this is a configuration. I should make I'm in an object-oriented programming language. I should stick with its strength. I should create an object that I can initialize and deinitialize and serialize and deserialize, and let .NET do its thing with the whole serialization. Maybe I can test it visually afterwards, but in the end, I want to be able to make sure that if I get an old config file, I get back a configuration object, and that when I save this configuration object, it updates it correctly. My test would have probably been no more than 100 lines. That's kind of a current goal of mine, is no more than 100 lines of testing code. It would have been pretty straightforward, where I would have had pre-made XML file. I would have said, this is the file, read it in, this is what I expect my configuration to look like. That would have been a lot less fragile. If I decided to switch to JSON or SQLite or insert other technology, would have been no big deal. I would have thrown away my XML serializer and put in the other one in its place, and life would have been so much easier. So much easier. I had wrote extension methods on top of expect as part of NUnit, but I wrote some extension methods to go along with this, so there's even more code behind the scenes that you guys aren't aware of that goes with this. I mean, this was at the beginning of my whole unit testing thing, and this is what kind of, it almost made me stop writing unit tests in general, because it was just, I forgot I wrote that. So it can get ugly fast. Now, where's my mouse?
That's a lot of ampersands and percentage signs.
You are not joking, huh? Oh, I had helper classes. I had so much stuff in there. It was pretty ridiculous there. But that was indeed a pitfall. Not using the strengths of the language that I was in. I was not using the strengths of it. That's all whatsoever. Another one that I am a little bit more happy with, but still had problems with. Red, we got failing tests here. I ran all the tests before I came here. The thing I wanted to show here was that the tests are fast. Now this is not all. Oh, this is from my personal log. Point of sale service object that I was starting to write on GitHub. I was starting to open source it. This was in continuation of my job that I was doing previous, but it had a lot more testing in mind. I wanted to start from the ground up. I learned a lot more about what testing should be and what shouldn't be. And as you see here, all of my tests run relatively fast with the exception of 1 or 2. I gotta interrupt myself. How long have I been talking anyway? It's like
7:50.
Okay, I see the time, but when did I start?
We're talking for almost half an hour.
Okay. Okay, good. They run fast. 23 milliseconds for some, less than a millisecond for other. 259 milliseconds, is at the top. The thing behind this that makes me happy is that I have fully tested that all of the properties that get read and write through a COM object are reading and writing properly. I'm asserting that they are using the notified property object. This is some .NET terminology. I'm sorry to throw it out there at you guys, but there's a lot to these tests that are more geared for testing the state or what it is doing to the state of my program instead of worrying about the details. And kind of the crux of what I want to keep pounding into this talk is that worry more about the big picture and not the small implementation of it. You'll avoid many heartaches that I had faced with it. The last thing with the, please pull up, is a game that I used to play back in the day, back in the late 80s, early 90s, Curse of the Azure Bonds. Don't know if anybody's familiar with AD&D games, gold box games. That's what I thought. There are some sides of me that are pretty nerdy, and then other sides I'm quite lacking, as Brian would love to point out. So this is one of the good examples, and I will show some of the code here, where writing good unit tests is going to be next to impossible. As you see here, I have some wonderful names: OVR015 tests, OVR017 tests. We know exactly what that means because it's a well-structured test. I know that, oh, I do have good method names here. This is actually, and this is the point of it. This is a characterization test. This is, go to it, open. Thank you, Visual Studio. Okay. Resolution Explorer. So we'll go to code backs in here. This is not my code. I will say that the majority of this code is not mine. This was decompiled from old school. What the heck is the name? Some C, some variation of C or C++. I forget exactly what the language was. It was decompiled into assembly, and then the person used IDA Pro to essentially take all the overall sections, hence OVR, and the segments of it, hence all the SEGs, and turn it into code. Now, as you can see here, there's a lot to it. He has only scratched the surface of what this is. And so in here, what I wanted to do was, I wanted to find a small class, hence what those test names were, OVR 15, if I can find it, text it to a small line. I was literally looking for classes that were relatively small, so 500 some odd things. And I wanted to find out what it did. I needed to find out, you know, when let's see, there's a public home here. No, text. I wanted to find out when locked door was called, what does it do? You know, this is one really large array of data. When they call locked door, what does it do? I didn't know. There was no tests around it. I had no clue how to figure it out. So I had to start digging into what does locked door actually do, and start writing tests around it before I actually started changing it. Because I mean, right off the bat, I'm like, ooh, we could reverse this equal sign, and I can switch this out, and I can do this, I can do that. I make all these wonderful changes and make it so much easier to read, but I'm going to probably break it if I do that. So the idea behind my characterization tests, although they are not going to be pretty, and although I'm probably going to have to delete them in the long run, the information they provide me is, how does this work? What does this do to my game state? What do I need to make this even work, so that if I did want to pull this out into its own helper class or its own state-driven whatever, you know, what do I need to get it there? What do I need to get it to that point? And through all my tests, I found that I was able to extract out a couple of different interfaces, and thereby make that particular section a little more understandable, a little more testable. I was able to pull out a couple of methods into a couple different classes, and because everything is static, and all the classes are static, all the methods are static, it's tough. Please, where's my display test? This one, I had absolutely no clue how to test. When the game first starts up, you know, it's an old CGA game. It pops up with the screen, it shows you the title of it, and then you actually have the credits of who wrote it, and then the next screen, another screen, another screen. I had no clue how it worked. I had no clue how the display worked, how he got that bitmap generated. So I had to go in there and figure out how it worked. So it turns out, hey, I had to set up these 8x8 symbols, I had to load up my 8x8 tiles, and then I could go ask my tile screen and then display my test. Now as you see here, I have, that's the entire test there, and I'll show you what that particular test did. It went over here on this screen, which you guys can't see. I can't find the mouse again. Tests. Characterization tests often make you have to do things like this. So that display test showed me these 5 screens. The very first time I ever ran this, that took 40 seconds, 45 seconds to run, because there was a class in there that I didn't know about that waited for keyboard input. Specifically, it wanted you to press A key so you could go to the next screen, but it timed out after 30 seconds. Was it 30 seconds? 10 seconds. 10 seconds per picture there, and that just took entirely too long. Well, I found out where that was. It was pretty easy logic. It was, get, there's some moving icons around here. I was able to pull out a small bit of the code. In fact, I'm going to go ahead and try to find it. I can figure out how to work
Fake keyboard input.
Huh?
Fake keyboard input. It's
Yes.
next to that.
Yes, and as you see here, I do absolutely nothing. In the implementation, where it actually uses in code, is that it sits there and it's in a constant loop checking for keyboard presses, and it returns that to its command handler, and there's a lot of backwards code. And I was like, all it's wanting to do is just get some sort of keyboard input. That's all it really wants, so that's what I'm going to give it. And I'll let it keep calling the code in the background. Where else do I want to go with this? I think that's all I really wanted to show from here, in that, you know, this test is small. I have a long road ahead of me in terms of this, but as long as I keep in mind not being too driven on the details, but instead take a look back and what they're trying to do. In this case, they're trying to press any key. I can extract that out, I can test that in isolation, I can now test my code, this other code a lot faster, and make sure that it's working properly. So that was a lot. Any questions, any things that's irritating you about writing out all your tests that you want to get off your chest? Or I'm sure there's quite a few of them out there.
Where's the A key?
I found it's if you hold down Alt and the F4 button. It works really good.
So you wrote all these tests on for this?
I did write all of these tests. He didn't have a single test beforehand.
That's cool.
Some of them are not the prettiest, but then again, they're characterization tests. By the time when I get done extracting everything out into little classes, and this is a truly state-driven architecture, the test will be a lot cleaner and so forth. But I mean, the tests that I have already, I don't think any of them are overly difficult or stupid, or I had to use a lot of what they had. Verified DAX array, 1D556, as you said. I mean, in their code, they have a variable called DAX array 1D556. I'm like, I have no clue what in the world that is, but I do know that in their code that you know, I need to check that all of my frames, all my pictures are null, all my delays are set to 0. You know, so I have a lot of helper classes that are going to help me test that this global. Oh man, she said it's global class. It's a nightmare. It's well over 2,000 lines long. So there's all my structures. There's some static bytes, some booleans, some bytes, some structures, some more. DAX bytes, ECL blocks.
Oh.
Well, right, because it came from assembly.
Yep, it came from assembly. And that's a completely different language. So I mean, yes, it's ugly to us, but I mean, remember, it was translated from machine code, and you don't read machine code very well. And there's your magic numbers nightmare. Class alignments.
No Sudoku, dude.
Oh, it's more than 9 lines. It's more than 9. Now that I see that, I'm gonna be angry when I have to start writing tests around that. 2D array. Oh, lovely. I promise you though that a lot of the other testing that you're going to do for more of your current frameworks are going to be a lot easier. One of the integration and acceptance tests that I was writing today, the logic is very simple, it's sound. It was easy I can't show it because it's not mine to freely share. But the entire test fixture that I wrote is, I think, 70 lines long. I've been able to refactor it 5, 6, 7 times, and I just keep running my tests, and they're all running under less than 100 milliseconds long, which is great because that's showing that they're not fragile. I can change things out. I've switched from an Hibernate to an entity framework, and my test still passed after I got the implementation working. So it can be done. It's frustrating. It's difficult. It's a long uphill battle, but once you get it, it'll make your life easier, I promise.